Great, this video is going to be a little bit longer because we have 3 topics being covered. First one is graphing absolute value using transformations. So if we look at example 1, we first need to identify what the transformations are. That +1 on the inside means we're shifting to the left 1, and the -3 on the outside means we're shifting down 3. There are no other transformations, no scalings or reflections, so we're going to keep our parent function pattern of over 1, up 1, and linear. So plot our point, left 1, down 3, and then we can go over 1, up 1, reflected over the axis of symmetry, and we need 5 points to make it precise, and then connect those with lines, arrows at both ends. So we should always have a V shape or an upside down V shape if there's a reflection. For example number 2, we have a vertical reflection because of the negative, and we also have a scaling by 2 since there's a 2 being multiplied on the outside. The other transformation is a +4 afterwards, so that means we're going up 4. It's always best to start with the shifts first, so we can plot our new vertex at 0, 4, and then instead of going over 1, up 1, we're going to go over 1, down 1, but then we have to remember we have a scale by 2, so we're actually going to go down 2. So it's like we have a slope of -2 for the right side, and then we can reflect it over on the left. Arrows at both ends, and we're done. Number 14 should be very, very familiar. It is a mastery topic for Algebra 1 and Algebra 2, so you guys should be pros at it by now. It's function notation, so we're plugging in -1 every time we see an x. Use parentheses, especially when you plug in a negative. And this is where everyone makes a mistake of multiplying before doing the exponent. We have to do -1 squared first. That gives us +1. Subtracting a negative changes to adding. 3 times 1 is 3, plus 1 gives us 4. Example number 2, we're plugging in 4 every time we see an x. So plug that in. Absolute value act as parentheses, so we should do 4 minus 8 first. We get -4 in absolute value bars. And then 2 times 4 gives me 8. The absolute value of -4 is +4, and then 4 plus 8 gives us a final solution of 12. If we look at topic 15, operations with complex numbers, that first one in example 1 is subtraction. So what we have to look to do is distribute that negative sign. It is not a multiplication problem if it's separated by a plus or minus. Multiplication is the example below where parentheses are squished together. So +1 becomes -1, and -6i becomes +6i. Combine like terms, -8 and -1 add to -9. And then +3i and +6i add to +9i. We're done. We cannot go further than this. For our second one, we've got a FOIL. First terms multiply to -15. Outside terms, -5 times 2i, -10i. Inside terms, +5i times +3 gives me +15i. And then my last terms, 5i times 2i is +10i to the second power. Now we have to remember I squared is equal to -1, so we need to use that substitution. So we get -15. When we combine our like terms, our two middle terms, we get +5i, and then we get +10, and then I had a typo in this, so this should actually be -10 because we changed it. Oh, sorry. Well, ignore me. I just didn't press far enough ahead of time. We can substitute in -1 for I squared. I did it right the first time. I'm okay. So then we've got a -15 and a -10, which combine to -25, and then +5i. For example number 2, we have to multiply by the complex conjugate, which means we take what's in the denominator and change the sign. So note that it was negative in the denominator, so our conjugate has a plus. So we have to multiply by that over itself so we don't change the value. And in the numerator, we FOIL. 8 times 7 gives us 56, and 8 times 10i gives us +80i. In our denominator, we need to FOIL since it's a binomial times a binomial. However, our middle two terms will always cancel out. 7 times 7 gives us 49, +10i times 7, -10i times 7, and we can see where that's where it cancels out. -10i times +10i, -100i squared. So we can write our numerator, we can't combine anything up there. In our denominator, our 70i and -70i cancel out. And we can also plug in -1 for that I squared. So we have 49 plus 100. So we get 149 in the denominator. We do normally have to check if we can reduce that fraction with the three numbers, but in this case we cannot. So that is our final answer.